All right, let's talk about the mean and the variance then of the continuous uniform distribution. All right, we want to find the mean and variance for the continuous uniform distribution. All right, so what do we need to do here? Maybe a bit of a refresher. We want the mean. Remember that the mean then is equal to the expected value of x. All right, so we need the expected value of x. And then the variance we can calculate as the expected value of x squared minus the square of the expected value. Minus the square of the expected value. So we really just need two calculations here to find the mean and the variance. We need the expected value of x, right? And we need the expected value of x squared. So let's start out with the expected value of x and just dive right into the mean. Expected value of x. Remember, for the definition of expected value in a continuous random variable, we integrate over all possible values of x times our PDF, f of x dx. So in this case, on the continuous uniform distribution, remember we're talking about f of x equals 1 over b minus a when x is between a and b. And so this is going to be the integral from a to b of x times 1 over b minus a dx. B and a are constants, right? So we can bring the 1 over b minus a term outside of the integral if we want to with the constant multiple rule. And so we're just going to integrate x dx from a to b. So this is so far so good. This is just going to be, what's the antiderivative of x? That would be x squared over 2. Evaluate this from a to b. And so we've got a little bit of algebra to work through here. 1 over b minus a. So this is going to be, I've got b squared over 2 minus a squared over 2. If I plug in my bounds. And so we have 1 over b minus a. And then what do we have here? B squared minus a squared over 2. Over 2. And so far so good. But I'd encourage us to not stop there. I'm pretty sure we can actually simplify this further. How does b squared minus a squared factor? That is a difference of perfect squares. So that is b minus a times b plus a. And we can see here now we've got a nice cancellation there and there. And so we're just left with b plus a over 2. B plus a over 2 or a plus b over 2. That is pretty nice. And once you see that, I wonder if you're thinking, oh, duh. You might be. A plus b over 2, that's just the average of your endpoints, right? Left endpoint, right endpoint, divided by 2, that's the average. Yeah, that makes sense. It's literally the middle or the average of your distribution. If you go back to just like a sample distribution, like right here, this goes from 0 to 3. Where's the mean going to be? That's going to be here, right at 1.5. Right in the middle, a plus b over 2. That's your average. It's uniform, right? The probability curve is flat. It does not change. So the mean is going to be right smack dab in the middle. All right. But we've proven it there. We've proven it. So that's kind of nice. All right. Good. So we're going to use that in the variance calculation, but we also need the expected value of x squared. So let's do that as well. The expected value of x squared, this should be a pretty similar integral. Just we're going to have x squared, right? So integrate from minus infinity to infinity. In general, this is x squared times f of x dx. And so in this case, we're going to integrate from a to be x squared times 1 over b minus a dx. And so the integration here is going to be very similar. I have 1 over b minus a, a constant multiple. What's the antiderivative of x squared? Now this is just x cubed then over 3. And we'll evaluate this from a to b. And so we're going to plug in our endpoints here. 1 over b minus a. Then this is b cubed minus a cubed over 3. And we might look at this and say, okay, do we have a similar strategy of factorizing this? That's not the right word. Factoring b cubed minus a cubed. Yeah, it's a difference of perfect cubes, Pull out your college algebra hat here. How does that factor? And I don't necessarily remember, if I go a long time personally without using this factoring, I will forget maybe exactly what it is, but I do know that it exists at least, right? So at the very least, we want to look at that and recognize as something that probably factors nicely. And then maybe we just need to go look that up online or in a book or something, right? So let's see, what does b minus a cubed factor into? This should be, if I'm not mistaken, b minus a, and then we have an irreducible quadratic term, and that is b squared plus ab plus a squared. Okay. And so what do we have here? B minus a's cancel. And the expected value of x squared then, I just reorder my addition. A squared plus ab plus b squared over 3 is the expected value of x squared. Kind of try to put this in a dashed box as a partial result, but our work here is not done. This is not the variance of x, right? This is just the expected value of x squared, right? Just the expected value of x squared. So what is the variance of x going to be then? It's the expected value of x squared, so it's going to be a squared plus ab plus b squared over 3 minus the expected value squared. So it's going to be minus a plus b over 2 quantity squared. Right? Pulling down the expected value there and then squaring it. All right, and so let's take a look at what we have here. A squared plus ab, b squared over 3, minus, now we're going to square the top here. Now we're going to square the top. This is going to be a squared plus 2ab plus b squared all over 4. This looks fine. And now we want to maybe try to combine like terms, but we're going to need a common denominator. We have a denominator of a 3 and a denominator of a 4. So our least common multiple there is, or at least common denominator there is going to be 12. And so what do I need to do to make this a 12 here? So I'm going to have to multiply the first term by 4 on top and bottom. So I'm going to have 4a squared plus 4ab plus 4b squared. 4 times 3 is 12 then, minus, we're going to have to multiply this by 3 over 3, the second term, to make that a 12. So then we're going to have 3a squared, 6ab, and 3b squared. And then that's all over 12. And now what do we have here to combine? 4a squared minus 3a squared is yada, 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 a squared. And then 4ab minus 6ab is minus 2ab. And then 4b squared minus 3b squared is 1b squared. And then this is all over 12. And so there is the variance. A squared minus 2ab plus b squared over 12. And actually, you might recognize that numerator, a squared minus 2ab plus b squared. That is, what do we have? What do we have here? This is a minus b squared over 12, right? Yeah, a squared minus 2ab plus b squared over 12. There we go. Looks good, looks good, looks good, looks good. What did I do wrong here? I'm slowing down because I'm pretty sure that is not the variance of a continuous uniform random variable. I'm pretty sure, if I'm not mistaken, we should have gotten that the variance, is equal to b minus a squared over 12. So I must have reversed an order of something here. What did I do wrong here? Where's the mistake? Let's see. A squared plus ab plus b squared over 3. I think that is fine. What about for sigma squared then? I've got a squared plus ab plus b squared. Looks good. Okay, so I have to multiply that by 4. Sure. Then I have to multiply everything there by 3. Oh, no, we're right. We're good. We did nothing wrong. Because this also factors into b minus a squared. These are equivalent. Right? These are equivalent. Is equal to b minus a squared. They are the same thing, right? If you take the difference of a and b and you square it, that's the same thing as doing b minus a and then you square it. These are in fact equivalent, right? Because this is b squared minus 2ab plus a squared, right? Same thing. Those are equivalent. If it's not squared, then they're going to be off by a factor of, they're going to be negatives. They'll be opposite each other, but they're the same thing. Okay. That's why I was just not expecting that. The general idea, or general consensus is it's typically written like this in orange here. So we have the variance of b minus a squared over 12, and the mean is a plus b over 2. And this is most commonly how you will see it written, as b minus a quantity squared over 12. Whew, yikes. There we go. So there's our variance, and there is our mean. Relatively simple results. Once we know them, now we just need to know what the a and b is, and we can find the variance and the mean. So like in the last example, when we had a in 0 and b as 4 here, a comma b, we know that the mean there is 2. And the variance there then would be 4 squared over 12, which is 16 over 12, or 4/3 would be the variance.